Hello and welcome to the fourth in the series of 6 films about the standard level equilibrium topic. Here we're going to be looking at how changes in conditions might affect the value of an equilibrium constant, and we're going to use Le Chatelier's principle to do this. So hopefully you've seen the previous film about Le Chatelier's principle, you know what Le Chatelier's principle states. In this film, we're going to try and see why some changes in conditions will affect the value of K, whilst others will not. We're going to start off by looking at temperature changes. And in this particular example, we've got A and B turning into C, and the enthalpy change for the reaction is positive. Remember, this refers to the forward process, and it should tell us that the forward process is endothermic. Okay, and the backward process is exothermic as a result. Okay, so let's just say that I've increased the temperature. What effect is an increase in temperature going to have on the value of my equilibrium constant? Well, if I increase the temperature, remember the system will try to lower it. How will it try and lower it? It will favour the forward reaction. Why have I chosen the forward reaction here? Well, because it's endothermic. Now, if the forward reaction is favoured, that means that some A and B is going to get used up and some C is going to be produced. And so the concentration of C will increase while the concentrations of A and B will fall. And that means that K will increase. Okay, so if I increase the temperature here, K will increase. This is not a rule for all reactions, okay, but it is true for this case where the enthalpy change for the forward reaction is positive. Okay, if I imagined a decrease in temperature, okay, I'll just circle this one in red so we can distinguish it. Okay, so if I decrease the temperature, what will the system try and do? It will try and increase it. How will it try and increase it? It will favour the backward reaction. Why? Because it's exothermic. That will use up some C, produce A and B, more on the bottom, less on the top, and so K will fall. Okay, so that's the deal with temperature changes and their effect on K. It's worth just saying at this point that K will never ever change unless you change the temperature. And in spite of the fact that people know this, or at least they're told it, they still fall into little traps, and maybe we'll see why in the next couple of slides. Now, if I make some changes to the concentration of my reactants or products, and I'm asked what effect will this have on K? Well, my quick answer ought to be no effect, because I haven't changed the temperature. But some people wonder, how can that be? Okay, if I add some reactant, let's say I add some A, and I increase the concentration of A. Well, that's bound to decrease the value of K, right? Because there'll be more on the bottom, and the top hasn't changed. But that ignores the fact that as soon as I increase the concentration of A, the system will try to lower it. And how will it lower it? Well, it will produce some more C. So C will start to increase. And how will it produce C? Well, it will use up some A and B. So those two things will fall again. And you might think, well, okay, in that case, C's increased and these two have fallen, so K will increase. No, because I initially increased this amount. C increased in response to that, and A and B fell, and so we're ending up in a situation where K hasn't changed. Okay, now the good thing is, you don't have to explain that, you don't have to worry about it. You can just say to yourself, if I'm asked what effect will changing the amount of A have on the value of the equilibrium constant, I can just go none at all, because I didn't change the temperature. What about if I change the overall concentration or the overall pressure? Well, again, the quick answer is no effect on K, because the temperature hasn't changed. But people get bothered by this, and if I increase the overall, let's say I made the, container smaller, right? So there's still the same number of moles of everything, but they're in a smaller volume, so their concentration has increased. That will mean that all these numbers increase. Okay, and in fact, let's say I doubled them all. Well, this would double, and this would double. So the top of the fraction would become twice as large. The bottom of the fraction would become 4 times as large. So K would have changed, surely. Well, that's ignoring the fact that if I increase the overall concentration or pressure, the system will move to the side with fewest moles to try and counteract that. Okay, so in other words, it will produce a bit more C and use up some A and B, and we'll end up with a situation where K hasn't changed. But remember, the short answer is no change because the temperature didn't change. It's just maybe worth mentioning what's going on here. If I've got a system, a slightly simpler system, where the concentration, where A turns into B and B turns back into A. Now let's see what happens if I increase the overall concentration. Well, the concentration of both of them will increase. What will the system try and do? It will try and lower the concentrations or lower the pressures, but it can't do that in this situation because there's equal numbers of moles on both sides. So if we think about what happens here, both these concentrations are going to change by the same factor if I'm changing the overall volume of the container, right? And so K won't change. But once again, the short answer is if the temperature didn't change, then K must never change. Please, please, please don't fall into a trap. They always ask questions of this type, where they say what will happen to the value of K if we add or remove this or that or the other, or change the volume of the container. If the temperature hasn't changed, don't get sucked in. Say there's no change to K. Okay? K will only change if the temperature changes, and then you need to think about which reaction is favoured. Okay, so we've reached the end of this film, and hopefully you can use Le Chatelier's principle to predict the effect of changing conditions on a number of equilibrium systems. Remember, we've done this before. This was just a little bit more practice at that. And hopefully you can also see why some changes in conditions, temperature changes, will affect K, but others won't. If you've got any questions or comments, please feel free to come and see me, or to post a comment on YouTube so that other people have the benefit of your questions.